Electron test key screencast. This is questions 1 through 3. Question number 1. Which of the following statements about an electron is true? Is it a subatomic particle? Yes, it is. So are neutrons and protons. Is it an elementary particle? In fact, electrons are. And does it have a negative charge? Yes. Does it have no mass? Well, that's where there's a problem. The mass is about 10 to the minus 27th grams. Now, in AMUs, they round it to 0, but that doesn't mean it has no mass. It has a very small mass, so it's not A. Is it a subatomic elementary particle with no charge? Well, all those are true except the charge part. It has a negative charge, so it's not B. Is it a subatomic particle with a negative charge? Good so far. Does it have gluons, up quarks, and down quarks? No, because it's an elementary particle, meaning they believe you cannot go smaller. So it's probably D, right? It's a subatomic particle with a mass far lower than a neutron or a proton. Yeah, all that is true. In fact, a proton is 1,836 times heavier than an electron. Answer to 1, D. Number 2, which experiment led to the original claim that electrons exist? You should remember that as Thomson's experiment. Okay, so it's not A. That was atomic emission spectra. That was the stuff that Bohr did that led to the idea of shells. Thomson's cathode ray tube experiments, you bet. His mass to charge data showed that electrons in fact exist, something 1,000 times smaller than a hydrogen atom. Rutherford's gold foil experiments came next, and those were the things that suggested a nucleus existed, since the electron is outside the nucleus. And finally, only a couple years ago, they started to get photographic evidence of electrons, but that is clearly not the original claim. So answer to 2 is B. Question 3, let's find out. Comparing an electron to a neutron. Well, do they have opposite charges? No. It should be negative and 0 there. That's not opposite. Is a neutron much more massive than an electron? Actually, it is. That's another error. A neutron is way heavier, but both those things are false. Okay, so it's not A. Are they both elementary particles? No, only the electron is. A proton is made up of smaller things. So it's not B. How about C? Do they both exist outside the nucleus? No, only the electron does. So it's not C. Well, let's see if it's D. They both have the same charge? No, we already figured out that's true. Do they both have the same size? No, we figured out that's false too. So it must be E. None of the above. This is the answer to questions 1 through 3 on the electrons test.